Good morning, my dear friends. Today we are going to discuss about multistage rocket. In yesterday's class, we detailedly studied motion of rocket and equation for that as well. In this topic, we will discuss the multistage rocket. Okay, this is relatively a small topic, but normally in today we are not using single stage rocket. Every rocket is multi-stage rocket only. So to take the higher payloads, higher to reach the longer distances, we generally employ multi-stage rocket. Of course, individual satellites or payloads may be very small. A single stage rocket may be sufficient to take to its orbit. However, we generally use multi-stage rockets to take multiple payloads such as different satellites in a single launch, because we know that after a launch, one single launch of a rocket, uh, launching pad needs 3 months time at least to repair it and make it ready for the next launch. So it is obviously economical to send number of payloads and heavy payloads. That means we are generally using the multi-stage rocket only. Okay, so the rocket depends upon the principle of jet propulsion. We already studied in the previous class. That is, jet is coming in one direction as an action, as an opposite reaction, as a equal and opposite reaction to the jet ejecting from the rocket. Rocket is moving in the opposite direction of to the direction in which jet is coming out. Okay, so according to the law of conservation of the momentum, the jet emerging in the backward direction makes the rocket to move in the forward direction, of course. So generally, if the opposite direction to the jet direction, only rocket moves. Okay, the velocity attained by the rocket is approximately 4 kilometers per second nowadays. To attain the higher velocities, multi-stage rockets containing 2 or more stages we are employing. Okay, not generally, even for high longer distances, as I told you earlier, even more than 3 stages also we are employing. For example, in case of 3 stage rocket, the first stage is very robust and heavy. The second stage is comparatively smaller than the first, and the third stage is smaller as well as the lightest. Okay, first of all, the first stage of the rocket is used to acquire the acceleration of the rocket, and the fuel of the first stage being on lower side is exhausted. It detached from the rocket and drops off. The velocity at this stage becomes the initial velocity of the second stage. Now the second stage is ignited and it starts functioning. What does it mean? Let me explain in this way, my dear friends. So initially, when the rocket is ready to launch, it is on the launch pad. The relative velocity with respect to the ground station, it is 0 kilometers per hour or 0 kilometers per second. So it is at stationary. The gravitational pull is acting on it. So initial velocity is 0. To lift off, so it requires great thrust. So initial velocity is 0. After it is burning for maybe around let us say 10 minutes of burning, it may reach to some distance, and it may reach maybe 4 kilometers per hour per second. I'm sorry, 4 kilometers per second velocity. Now if we start igniting the second stage at this level, the initial velocity is 4 kilometers per second. Now with the 4 kilometers per second velocity as the initial velocity for the second stage, So that means thrust, the moment or the acceleration is more, and that means the result is more. And most important thing we should analyze over here is in the first stage, second stage. When I say first, second, third stages means generally every stage itself a full rocket. Actually speaking, every stage itself a full rocket. What is exactly rocket is? It contains, first of all, the fuel. It contains oxidizer as well, and both the fuel and the oxidizer get combusted in the combustion chamber, and the jet is coming from the nozzle, and rocket is moving in the forward direction, whereas the jet is coming in the backward direction. Okay, so this is simply a rocket. First stage means first stage contains all these things, like that means it contains oxidizer and no combustion chamber and the fuel and the nozzle and everything. Okay, so that means actually first, second, third stages means actually there are three rockets. Actually speaking, there are three rockets at different stages. We are igniting different rockets. Okay, so because we are fixing together and bring the rocket shape for the entire thing, we call it as multi-stage rocket. That's it. Actually every stage. That means why I'm telling you this is, see, to lift off huge payloads like 4000 kgs or like that, about 3000 kgs, and even reaching up to Saturn, Mars and like that. So it's a huge amount of oxidizer, huge amount of fuel is required. So oxygen fuel actually stored in some type of cylinders, that too because they are liquefied things. So actually what we the containers, the technology we are using, the containers also very heavy weight in weight, like they are in tons. So even if you get rid of the say for example, let me explain in this way. If you required 4000 of say for example 1000 kgs oxidizer, 1000 kgs fuel, so to keep 1000 kgs oxidizer and 1000 kg fuel, you require tanks. Even the tanks itself very weight. And most importantly, if rocket is continuously same combustion chamber is combusting, and same nozzle is burning for more time, creeping will come into picture. That means the nozzle function at higher temperatures, it will not function properly. So it is not wise to have a huge rocket, a single stage, only one stage rocket. So it is a good idea to have different stages. Okay, so that is, my dear friends. Okay, so if you get rid of the fuel tanks and everything, so losing some weight means it features a lot in the momentum. Okay, so the rocket gains acceleration and its velocity goes on increasing. The removal of the surplus mass contained in the first stage considerably helps in attaining the higher velocity. Okay, so we get rid of this old already burned nozzles and engine, and get rid of the cylinders, fuel cylinders and oxidizer cylinders. So definitely it will fetch in the velocity. So when the fuel of the second stage is exhausted, it detached from the rocket. So, okay, so the velocity acquired so far by the rocket is less than the escape velocity. We know that, my dear friends, 11.2 kilometers per second is the escape velocity. Finally, the third stage rocket starts off with the required velocity. Okay, so see, my dear friends, this is the Saturn V launch vehicle. So Apollo spacecraft, this is instrument unit. You can see the third stage S4B, second stage is S2, first stage is S1C. Okay, see, my dear friends, you can clearly observe that this see, this is this is one nozzle, another nozzle, like that. So actually these are the boosters. Let me tell you one thing, each booster is a one rocket. Okay, so let us read this. So the length of the vehicle is 281 feet. Length of the total vehicle, this one, 281 feet. So length of vehicle spacecraft. Vehicle spacecraft. They are the 363. Weight at the liftoff. See, 6,400,000 lbs. Such a huge weight when it is lifting off. So obviously the first stage is very robust, that is why we are employing big thrusters and everything. At the last stage, see, single engines. Okay, so the transcendent payload capability is 107,350 pounds. Okay, so Earth orbit is two-stage vehicle, 212,000 lbs, and stages S1C stage, that is size is see my dear friends, 138 feet. Okay, 33 feet dia, 33 feet dia, and 138 feet is the length. This first stage, my dear friends, this first stage, and this dia is 33 feet. So engines are 5 engines, you see, 1, 2, 3, 4, and 5 engines. They are the F1 boost, F1 engines. So boost is so the thrust is C. Thrust is 7,610,000 pounds. So propellants are LOX and RP1. See, come to the second stage. See, the engines are 5 F1. I'm sorry. Engines are 5 J2. And 1,150,000 pounds. Propellants are LOX and LH2. And third is third stage, so 4B stage, that is size is 22 feet and 59 feet. So this is the third stage, dear friends. So 59 feet only. This is 138. Okay. So engine is single engine. See, this is J2 engine. The thrust is 230 pounds lbs. The propellants LOX and LH2. See, you can get rid of the entire weight. When you get rid of this entire weight, so it fetches a lot for the remaining step. Even after the second stage, you get rid of this. So all this dabbas or everything will fetch you because we are get rid of the weight. Okay, instrument unit size is just 22 by 3 feet, 3 feet height and 22 feet dia, and the guidance system is inertial guidance system. Okay, so that was the NASA's one, and this is our proudly Indian ISRO. So this one is nothing but GSLV Mark 3. GSLV Mark 3, even for Mangalyaan and all these things, we are using this for heavy payloads. Okay, so the vehicle specifications are this, my dear friends. We are generally using the SI system. So 43.43 meters. So vehicle diameter is 4 meters, and heat shield payload firing diameter is 5 meters, and the number of stages are 3 stages. Lift of mass is 640 tons. Okay, technical specifications: payload GTO 4000 kgs. In GSLV Mark 3 will be capable of placing 4-ton class satellites of GSAT series into the geosynchronous transfer orbits. Payload to LEO, that means low Earth orbit. LEO means low Earth orbit. Low Earth orbits, this Mark 3, GSLV Mark 3 can take even 8,000 kgs. It can take. The powerful cryogenic stage of GSLV Mark 3 enables it to place heavy payloads into the low Earth orbits of 600 kilometers altitude. Okay. Low Earth orbit, my dear friends, I need not make you remind that in the low Earth orbit only our International Space Station ISS is moving. Okay, so cryogenic upper stage is cryogenic, that is C25. C25 is powered by CE20, India's largest cryogenic engine, my dear friends. You can see the picture of the cryogenic engine C25, developed by the Liquid Propulsion Systems Center. Okay, so Cryostage height is 13.5 meters. Cryostage height is 13.5 meters. Cryostage diameter is 4 meters and engine is CU20. Fuel is 28 tons of LYX and LH2. Okay. Solid rocket boosters S200 GSLV Mark III uses two S200 solid rocket boosters to provide the huge amount of thrust required for liftoff. The S200 was developed at Vikram Sarabhai Space Center. Booster height is 25 meters, booster diameter is 3.2 meters, fuel is 205 tons of HTPB nominal. So you can see this strap-on boosters, they are nothing but this. I am talking about this boosters, my dear friends. This the air booster is itself. The air booster itself. So this is booster, and this is again another booster. So just for the lifting off. Okay. So more thrust is required, but because initially it is very heavy, so that is why. So here are the boosters, you can see them. So core stage is L110 liquid stage. The L110 liquid stage is powered by two Vikas engines designed and developed at Liquid Propulsion System Center. Stage height is 21 meters. Stage diameter is 4 meters. Engine is two Vikas engines, and fuel is 110 tons of the UDMH and N2O4. Okay, this is all about the multi-stage rocket. All the rockets today we are employing are the multi-stage rockets. Okay, my dear friends, thank you.